Hi everyone, this is Sridevi, Professor ECE. In this video, we are going to learn about coordinate systems. On completion of this video, the learners can able to understand the basis and application of coordinate systems. Basically, the coordinate system is classified into three categories. First one is Cartesian coordinate system, cylindrical coordinate system, and spherical coordinate system. Cartesian coordinate system is represented by the parameters x, y, z. Cylindrical coordinate system is represented by the parameters rho, phi, z, and similarly spherical coordinate system is by r, theta, and phi. So before starting that coordinate system, we have to review the vector algebra and vector calculus. So vector algebra deals with scalar and vector products, unit vector, position vector, and distance vector. Vector multiplication, that is two categories, dot product and cross product. Vector addition and subtraction, similarly the problems deals with this all categories. And these three types of coordinate systems are used to analyze electromagnetic waves. That is, basically a scalar is a quantity that has only magnitude, and vector is the quantity that has both magnitude and direction. A vector A is represented as A is equal to ax into ax vector plus ay into ay vector plus az into az vector. Simply, it is ax, ay, z, az. Ax vector is the unit vector along x-axis, ay vector is the unit vector along y-axis, and az vector is the unit vector along z-axis. It has the magnitude that represented by modulus A. Modulus A is represented as square root of ax square plus ay square plus az square, and the unit vector of A unit vector is equal to A divided by determinant A. The position vector and distance vector. A point P in a Cartesian coordinate system may be represented as x, y, z. The position vector Rp or radius vector of point P is directed the distance from the origin O to P in such a way that Rp is equal to O to P, that is OP, that is x into ax vector plus y into ay vector plus z into az vector. So this is the diagram of Cartesian coordinate system. Here we are having three axes, x-axis, y-axis, and z-axis, that is mutually perpendicular. And P is the point which is represented by the points x, y, z. That is P of x, y, z is represented in Cartesian coordinate system in such a way that x should be in between minus infinity to plus infinity, and y should be in between minus infinity to plus infinity. Similarly, z is also in between minus infinity to plus infinity. Ax vector, ay vector, and az vectors are the unit vectors along x-axis, y-axis, and z-axis. And this is the Cartesian coordinate system. In this Cartesian coordinate system, a dot ax is equal to ay dot ay is equal to az dot az is equal to 1. So here you are having x, both are x coordinate, means if you are taking dot product, and similarly both are y coordinates and both are z coordinates, and you are having dot product, means that is equal to 1. If you are having the cross of xy, yz and zx, means that value is equal to 0, that is ax dot ay dot az dot ax, that value is equal to 0. So its magnitude is equal to root of ax square plus ay square plus az square. And this is the cylindrical coordinate system rho, phi, z. A point P in a cylindrical coordinate system is represented in such a way that rho, phi, z. 0, that is rho is in between 0 to infinity, and phi is in between 0 to 2 pi. Z is in between minus infinity to plus infinity. This is the way in this coordinate system you have to represent rho, phi, and z. And cylindrical coordinate system having a rho dot product between rho and dot product between phi and dot product between z is equal to 1, and the remaining combination of rho, phi, z should be 0. And here cross product between these two is equal to a rho cross a rho is equal to a rho. Similarly, a phi cross a phi cross a phi is equal to az cross az is equal to 0. And here the magnitude that is represented as modulus A. So modulus A is equal to square root of a rho square plus a phi square plus az square. and it is represented as mod a divided by modulus a. And this is its spherical coordinate system. It is represented as r theta phi, and a point P in a spherical coordinate system is represented in such a way that which is shown in this diagram, and r is lies in between 0 to infinity, phi is lies between 0 to 2 pi, and theta is lies in between 0 to pi. AR, A rho and A phi are the unit vectors along r, theta and phi axis. And here they taking the products, AR dot AR is equal to A theta dot A theta is equal to A phi dot A phi is equal to 1, and remaining product should be 0. And while taking the cross product, R cross AR is equal to A theta cross A theta is equal to A phi cross A phi is equal to 0, and the magnitude is equal to modulus A is equal to AR square plus A theta square plus A phi square. And this is the transformation between xy to rho phi z. Xy z to rho phi z is equal to rho is equal to square root of x square plus y square, and phi is equal to tan inverse y by x, and z is equal to theta, and phi z is equal to x is equal to rho cos phi, and y is equal to rho sin phi. Similarly, xy z to r theta phi is equal to r is equal to square root of x square plus y square plus z square, and theta is equal to tan inverse of b by a, that is tan inverse of y by x, and x is equal to r sin theta cos phi, and y is equal to r sin theta sin phi, and z is equal to r cos theta. And the application of coordinate system, it is used in GPS navigation and mapping in GIS, CAD and CAM for designing mechanical parts and physical and electromagnetic ways to represent Cartesian and cylindrical coordinate system. Hope you all understood this session. Thank you.